Okay, hi everyone. I think we can start. So this session is wearing many red hats, multifaceted container management. My name is Federico. I'm just gonna be introducing myself with a couple of words, and then I'll let Steph introduce himself as well. I joined Red Hat 5 years ago in Rev, and after a while, when the containers technology got really into some pace in the community, I discovered this amazing technology, and I really wanted to work with it. So I started by doing an integration between Rev and containers, and then I moved on, working full-time with containers 1 year ago, starting to manage the container management team. And today I'm going to present you what we have been doing so far.
I'm Steph Walter. I'm a bit of a usability and integration freak. I've contributed to over 100 different open source projects, and what I love doing is building the glue between these things and integrating, making them work together. And in the container space, we see a lot of that going on.
Okay, so the agenda for today is pretty simple. We have 3 items here. We don't come here with any assumption for you to be aware of what containers are. I'm pretty sure you already took many sessions about them, but we really want to start from the beginning of the story. So we're going to start by diving into containers, giving you a few details about how you can start getting your feet wet with containers, and then move on and see how you can grow from there and starting having your infrastructure, whether it's public or private infrastructure, doesn't matter, we got you covered. And then finally, we'll see how management ties these all together in the third part of the talk. There will be elements of management all across these 3 items. At the beginning, there will be very minimal, maybe some troubleshooting and so on, but the management of all these aspects is going to be tied at the end. So I just want to point out that what we're seeing today with containers is something that we already saw and learned from other technologies. You might have a developer that wants to start experience this new technology. And then you have that being contagiously touch other engineers, and soon you will have a team working with that technology, and then multiple teams. And then you don't realize, and at some point you need one infrastructure or multiple infrastructures supporting this new technology. And then you reach the point where the scale grew so much, you have so many teams and so many infrastructure that you're not able to control them anymore because of their complexity, because the complexity grows exponentially with the scale. So we want to give you a solution for all this complexity that has to be managed somehow. So this diagram here is kind of summarizing all the points that we're going to touch today. We will be focusing mostly on the right side of this diagram, where the management and the initial part of the containers is placed, and we are going to cover also the bottom side of this left side about the container OS and the infrastructure, so that you can see what are the elements there out of the box that you can use for troubleshooting. So let's start and get ready with the containers. So again, as I said, we don't take for granted that you know what containers are. You might want to start building your own images, testing that out, test the technology out, and then maybe even converting your old applications to containers. So the solution for that is what we have on the graph that I showed you earlier, the CDK and the Developer Studio. Those are solutions that were designed for you to easily experience the containers on your machine, laptop, as if they were in production. It doesn't matter if you have Windows on your machine or Linux. It's easy to set up. I'll show you later on how you can do that. slightly, and then you just have to download this package, which is nothing more than a Vagrant box that comes with Openshift and Kubernetes, so that you can start playing with it. It comes with many handy examples. Doesn't matter if you're familiar with Python, Ruby, or Node.js. There are plenty of examples for each and every language, so that you can learn from them, start playing with them, and then move on and build your own applications. Additionally, obviously, you have the tools for building and deploying. And the idea is that you just get to the Container Development Kit site. You download the kit, as I said, the additional components with the your likings of languages and additional examples that you want. You install them easily, double-click. You start them. You start the virtual machine on, and you build your first container. Super easy for you to start with these. And obviously, that's not all that we have. We also have an IDE for you to build your applications and images. It's very well tied with the CDK. You can leverage all the syntax highlight, all the automation that you have here to build, run, and ship your containers. And you also have a part where you can visualize what is your current application. That's the beginning, because you don't have yet management. I want to highlight here that there's no management whatsoever, because you don't need management at this point. You're learning the technology, right? You want something that's easy to install, easy to run, and easy to understand. There's no real management. But you can take a little step further if you want and start looking at Ansible Container, which is a new project that it allows you to embed the building and the shipping of the images using Ansible. So you might have already some operations going on, some playbooks, and you can start delivering your application with containers embedding Ansible Container into these playbooks. It is fairly compatible with Docker Compose, so you can leverage all the applications that are out there already written for Docker Compose and have them deployed, built and deployed using Ansible, together with the automation that you already have in place in your lab. And these will also allow you to bridge to OpenShift, because as the next step that comes out of these is the ability to run these images that you built and prepared onto OpenShift. And that's where it takes me to the next step, which is how to set up what do you get from the infrastructure that Steph is going to show to you.
So many of you are done exploring containers. You've gotten past that step, and now you're ready to run them, to deploy them. You need container infrastructure. There's a lot to container infrastructure. We're going to look at this part of the graph here. In fact, we're going to look at 3 pillars in particular. We've chosen these to give you an example of the container infrastructure and the management of those aspects. Here, we have an operating system, a container operating system, atomic host, orchestration platform, Openshift, and an image registry, the atomic registry. Let's look at the first one. A container operating system is not just an operating system that runs containers, but it is built with container principles. These principles have emerged, and you'll find this in Red Hat Enterprise Linux Atomic Host. It'll run containers really well. It's a pared-down operating system targeted at that specific task. But it also is delivered in the same way as a container is delivered, as a unit that runs to do its task. It's not assembled on site. It's pre-assembled and brought there and runs there. In addition, when you upgrade it, when you change it, when you roll out a change to this operating system across a cluster, it is atomically updated. You're either running the old version or the new version, not some piecemeal mix of the two. I'm calling out some specific aspects of this container operating system. There's a lot more to dive into here. Colin Walters is talking about OS3 in particular, I believe tomorrow, so check out that talk. You can then dive into this operating system to explore it, to discover it, and to troubleshoot it. There's a project called Cockpit. It comes in Atomic Host installed. It's very lightweight. You can interact with the containers on the host, other aspects of the host, its name, its affiliation to a domain, its networking, its storage. Let's take a look at an example here. Here we're logged into an Atomic host. You can see here we're running Red Hat Enterprise Linux Atomic Host 7.2, and we have, well, it's a very poor name there. We can do all sorts of things. We can adjust a performance profile. Let's look at a video. Let's log in. I'm pointing out different things here. We can change the performance profile and adjust various things like this directly. See their effect on the system, what's going on there. We can connect to the Docker instance on that Atomic host, explore how a container is running, what we can dive into that container. There you go. We can see its log output. We can start a shell in the container, although I don't think I do that here. We can change the limits of memory, CPU, check out how much it's using in different situations. And essentially, we're doing troubleshooting and discovery tasks. Look at the logs, what has occurred on this system, and so on. You can begin to see the beginnings of management at a host level here. And obviously, working with storage. Let's skip ahead. This is pure UI, the presentation tier of a three-tier application. The logic tier is really the operating system here. The various parts of that operating system, systemd, Docker, Kubernetes, these are all pieces that are delivered inside of Atomic Host. And what you're doing when you interact with it is purely interacting with those services. There's no management value add. You're driving it directly and exploring it. We can also connect out to multiple machines here using SSH. So you have instances in the cloud. They're not exposed. You don't have browser access to them directly. You can log into them via SSH. Let me show you that. Here I'm on a RHEL server system, and I can go add an instance, an Atomic Host instance, to my dashboard to connect to it. You see that we're connecting over SSH. There's the SSH key. And I need a specific key, as you do with cloud providers, to connect to this host. I'll load the SSH key that I need. And all of this can be done interactively. It goes without saying that these same tasks can be done via SSH or on the command line. Then we connect to that system, and we can, let's do an upgrade. Let's take a look at what that involves. Here we're running Atomic Host 7.2.4, and we have an update available, 7.2.5. That actually just came out a couple days ago. And here we can see the bits that have changed. Updates, additions, removals. That gives us an idea. Now, obviously, we could click this button here to upgrade to this new version of the operating system, and you might do that as a canary to test whether that version works well, whether it regresses any of the applications or containers that you have running. But better, let me show you upgrading this system and other systems via Ansible. We're going to run an Ansible playbook to do that upgrade. As you would expect, the UI is reacting to that change. We can see that this is now running. And we're going to boot into the new operating system. The system reboots. We can connect to it. So whether you're doing these tasks at scale or not, it's easy to dive in and interact and make this stuff happen. So now we're running the new version of the operating system, and obviously we can just, if something doesn't work, we can roll back to exactly the state that was running before and recover from that. So let's move on. The orchestration platform. When you have containers and you need to wire them together, you need an orchestration platform to turn those individual microservices into an application, and that's Openshift. And we could talk for hours about Openshift and its capabilities. Everything from the deployment of applications, of microservices, how they talk together, all the way through to CI, rolling updates, canary containers. And the list goes on and on. There are many talks here, and I encourage you to go to them. Check out the booth downstairs about Openshift as well. Openshift is structured in such a way that there's a master that's orchestrating across a cluster. And we can see here are a bunch of nodes. These can run Atomic Host. Atomic Host is really well positioned to run the containers that the master schedules on them. Let's take a quick dive into one aspect of this. It's based on Kubernetes. In real industry standards, this is not its own little island. And there's a fundamental concept here of taking containers and grouping them together into pods when necessary. They can share security. They can share a network configuration, even if they have disparate file systems. And Openshift comes with a developer console where you can dive in, scale, deploy, work on templates, iterate on images, and check out what's happening from development through to production in a DevOps style. And there you can see an example of an application with multiple components. I wish I could go on about Openshift and the aspects of it, but we don't have time for that today. So let's move on to the last pillar that we were talking about on the infrastructure, the registry, where you store the content of those images and curate it, mirror it, and review it, where you scan it. We're going to come back to that. Atomic Registry is a pared-down version of Openshift. Openshift contains a powerful registry with many, many capabilities. And you can start off with Atomic Registry, a standalone version of that. Bring your authentication, storage. You can interact with it in various ways, browser, via an API. You can have access control. And you can grow from there into Openshift. Exactly the same capabilities are available for you. Here's an example of how it looks when you log in. There's a self-service UI for users. And actually, I'm going to show you some examples of how it works. Here we are. We have images uploaded to this registry already, various projects. We can organize images by projects and assign them various access rights. And we have commands to interact with this registry from the Docker command line. So here's an image stream which contains multiple images. We can, of course, dive into one of them and look at information about that image, as well as what the container inside of it would do, its environment, the network ports exposed, and the layers, how it's built. We can adjust who can access the image. Let's create a new project. Let's give it the name test. And we can choose our access methods. And there's nothing yet in our project. So let's make a new image stream. We're going to call this MySQL. We're going to use it as a stage for other images that we push to this project and a basic dependency, one of the services in this application. And we'll use that. We'll log in from the command line. We can just copy and paste these commands over here. And let's go into our image stream. We can copy this command to the command line. And we're going to create we're going to tag the MySQL image into our new registry. This is how we can manually copy an image if we want, and of course, push that into the registry. As we do, we're going to see it take a moment, so I'll skip ahead. Let's skip ahead, and there we go. We can see this is happening, and we're done. And there's the image that's appeared in here, and as you can see, it is MySQL. There's the various layers that build up that make up that image. But if we would like to, we can also pull in images from another repository. Let's say you have a production and a development repository. We can choose what to mirror between the two, or mirror stuff from the Docker Hub. There we go. And we can see this being populated here. There we go. Lots of different versions of MySQL have come down in this case. And we can see the tags. We can edit those tags if we want specific images to be mirrored. And obviously, we have the full abilities to adjust things like access control, who can push images, who can pull images, who can admin the various projects. So, as you see, you can always interact with the infrastructure. You can dive in and do things. And you can discover it, but that's not enough. When you deploy this on a broad scale, when you have clusters in production, you want to be able to manage them from a single pane of glass. You want to be able to see what's going on across all of this. And for that, I'm going to hand it back to Federico.
Thank you, Steph. Yeah, that is correct. Because in fact, what you saw just now is how to troubleshoot and inspect what is going on in your single OpenShift cluster. And that is good enough if you want to have a small lab where you run your application. You might be able to do operation across 2 different clusters, but for more than that, you definitely need to tame that complexity. And for that, I'm going to introduce CloudForms. So I'm not sure how many of you might be familiar with CloudForms. You can raise your hand maybe if you know what it is. OK, so I'm going to introduce a little bit CloudForms, not so much as I saw that you're slightly familiar with it. So I'll start from the underlying infrastructure, and then we'll come to containers. For a much longer discussion about this or a presentation about this, there's another session tomorrow, 4:45 in room 2004, so feel free to come there, and we'll go much more into details on CloudForms and the advanced container management. And today I'm going to present you a few of key points out of that, basically. So let's introduce CloudForms. It is your single pane of glass for monitoring and management of your infrastructure, whether they're private or public cloud or virtualization solution. It is basically collecting all the information, the entities, all the metrics, and all the relationship of your entities, VMs, instances, clusters in your private or public infrastructure. But it's more than that. It's not just the visualization, the clear visualization of these resources that you have out there among different solutions. It is a management framework, which means that all these entities that you see nicely in the UI, you can actually work with them with code. Right? You can write your own code against these entities, their relationship, their metrics. And not only that, you can write policies and alerts, and I'll go more into details of what those are, and automation to automate the tedious tasks that you might have in your infrastructure. Those automation can be tied in your workflow of your organization and with some kind of glue that you will come up to integrate those in your enterprise. There's also the capacity planning that I want to mention. So basically, we learn from past utilization of your cluster. And from what we learn, we warn you about what might happen next month, right, or next week, so that you might notice that you're running out of computational power, memory, or storage, or what else. So let's start by what you see as soon as you log in. So this is a CloudForms web UI where we already added several providers to it, whether they're public or private. Doesn't matter. You see here that there are many, there's a lot of information for you to look at. There are reports and charts, and these are the ones that are out of the box. So we came up with a good set of reports and charts that might be useful for you as soon as you log in. But these are not fixed, are not just simple reports and charts. These are actual implemented as features inside CloudForms. So you can come up with your own reports, with your own charts, because as I said, everything that we collect and we store inside CloudForms can be acted upon as an object and together with its relationship with the other objects. And so then you can do accumulation, slicing of data, come up with your own reports, and then tie those reports to some charts. As I mentioned, it's a single pane of glass, so there's some transparency here. And as you see here, you can look at the VMs in a transparent way, whether they're running on Rev, OpenStack, VMware, or externally on Azure, Amazon. In the UI, they're slightly separated, but when you write policies and code, they're actually transparent. So you write your policy once, or your alert once, and that will work across all the providers. Of course, if you don't want that, you can, again, change and make policies and alerts working only with a special one of these providers. This is an example of a policy. You might not be able to read it into it, but it's a policy that has to do with the compliance check. So we are able to do compliance check against VMs, instances, and containers as well, but we'll come to that later. And basically, we allow you to create this logic up here, this condition that is a logic that is applied to your object, and an action that is taken after that condition is evaluated and found positive. So on compliance check, we evaluate, in this case, it's a shell shock vulnerability check. We look at what packages are installed in your instances or virtual machines, and we are able to tell you if they're vulnerable to the shell shock vulnerability. And then we take some action, like sending an email to the security team, mark the VM as not compliant, and many other actions if you want to. This is based on another feature of CloudForms, which is the ability to crack open the images of virtual machines and instances and look at what are the packages. And we replicated this feature with containers as well. So I mentioned alerts. So we saw policies. Alerts basically are notification of changes in your object or warning of a certain threshold limit reached. on this notification, you can do simple actions like emails, SNP traps, or timeline notification. We'll see about that. And events. The events allows you to then chain policies actions on with alerts. And again, as I mentioned every time, this is all based on the objects that we collect together with their metrics and relationships. So this is an example of an alert on threshold limits of less than 5% free space in your data store, then this alert is triggered. Maybe an email is sent. Maybe an SNP trap is sent. Maybe it's chained with some automation, right? So these are the starting point for your notification. So now that we defined a little bit what is CloudForms, what are the features and what is capable of doing, right? We just saw what is able to do on the infrastructure, right? We covered this part here, where I mentioned Rev, OpenStack, Amazon, GCE. Now, we actually really want to see what happens with the containers, right, with Openshift. And not much surprisingly, right, CloudForms can connect to Openshift as well. We added the provider for Openshift 1 year ago. And Openshift is a very special provider because it actually stays on top of your infrastructure. So we are collecting all the entities from Openshift, the majority of them. Openshift has a very vast park of entities. And we connect them so that you can travel from services to pods and containers, but also reach the underlying part of nodes, right? So you can say that a service is connected to a certain set of pods, and those pods are running on multiple nodes, and see what are those nodes, right? And then also see what those nodes, right, are implemented upon, right? On some instance, maybe on Rev or on OpenStack. So we added this relationship not only within the same provider, but also across providers. So now, what you're not able to achieve by writing automation policies and so on in this realm, you're able to do it in this other realm, right? And cross-correlate information, such as the metrics that we collect here with the metrics that we collect in the underlying instance. And to present you how the Openshift provider looks like inside of CloudForms, there's a video that we can actually watch together. So this is the dashboard, the very opinionated dashboard for containers, where we show you all the metrics that we collect from Openshift about the node utilization, memory. This is across all your providers. Multiple cluster of Openshift. So you have multiple cluster of Openshift, and you tie them all together, and you see them together. These are all the projects that are collected among all the providers, all the cluster of Openshift. You can obviously filter them if you would just want to concentrate on a single provider. Here you're seeing that we're following the relationship from a service where we all have all the information for you to look at, but again, that you can leverage with your additional code. And we follow and we find a node, and we see that it's running on underlying instance of Amazon. So we know what is the node and what is the underlying infrastructure. Here I'm showing you that we are collecting the metrics for that single pod, and it's not just collecting collecting the metrics of that single pod. We are able to do aggregation across multiple pods with logical entities, such as services, right? Because you want to be able to say, okay, how much this service is costing me in terms of resources, or how much is this project costing me in terms of resources. And these that you see are the accumulation of the metrics across all the pods that are realizing that service or project or replicator. Now we are following another relationship to go back, and there are another couple of things that I want to show you. One is that there's a specific dashboard for each provider so that you can see, again, the same data, but for the single provider. Again, following another relationship, here you go to the topology where you see all the details about the relationship of the entities. So you see the provider connected to the nodes and the pods running on those nodes. The color are telling you whether there's some problem going on or not. There's also an additional thing that I want to show you because I mentioned earlier the timeline. The timeline is where you see all the events happening in your cluster in a timely fashion manner. And basically, as you see here, we have several events happen real close to each other. We have all the details. We are working really hard to improve this going forward because we know that the amount of events that are coming in from a cluster of Openshift is very large, and we want to be able to display them consistently in a very clear way, so you'll be able to zoom in, zoom out, group them, and so on. So again, these are all the highlights. So running the containers is not the end of the story. So just running them is giving you functionalities, but that's not enough. You want them to be trusted. You want them to be secure. You don't want malicious people to be able to take advantage of your application or your infrastructure. And so that is why we introduced the integration with OpenSCAP. So by running a scanner inside of your cluster, we are able to crack open the images as we do for VMs and for instances, and not only look at the packages that are installed into these images, but we are also able to run OpenSCAP on these images and collect the result of the rules that were evaluated. And that's not it. On top of that, we are also coming with a policy out of the box that is basically giving you the reliability of checking whether there's any result of high criticity of those specific images and prevent those images from running. So basically, we added a new action which is able to annotate these images inside of Openshift with special annotation so that Openshift is aware that the policy attached to the OpenSCAP scan in CloudForms failed. And Openshift can take advantage of this annotation to take action. Again, you'll probably won't be able to read it, but this is how the policy is not only displayed, but it's also how you can modify it or even create your own new policies. Anyway, what it says is that on the condition met of the vulnerability severity high, we are taking some action. We are marking the image as not compliant, and both within CloudForms and Openshift by using annotation. We also have an history, so you can go back in time and find out when vulnerability was discovered, because you have to think that the vulnerabilities are discovered over time, so you have to keep scanning these images over and over, and we take care of that. We schedule this scanning once a day. You can tweak that as you want, but anyway, once a day we check for new vulnerabilities over these images, and then with this history you can see when the compliance check failed. We are also able to give you the OpenSCAP report by regenerating these out of the results that we collect, because again, we collect the results, and again, these results can be acted upon as any other object inside CloudForms, policies, alerts. And we are able to regenerate the OpenSCAP report that you might be familiar with, and you know how useful it is. It has links to the CVEs, to the resolutions, all the details. It is very dynamic. You can select which CVEs are you interested in, and more than that. Again, another thing that you might be interested in is how much a certain project is costing me, because you might have multiple departments, multiple teams running their application, and you want to be able to say, okay, this project is way too much intense for this type of infrastructure. We might want to move it somewhere else. And we are able to do that to identify how much a project is costing and whether it's the case to move it somewhere else by using the Chargeback. So Chargeback was already in CloudForms, and now we are extending that to containers. So basically, based on the CPU core usage, memory, and network, you're able to define rates. And using those rates, you apply them to the providers, and you come up with the monetary consumption of a certain project. So I have a short video here. We'll try to go through that. Let's see.
We have time.
Yeah.
Let's look at it.
Yes, we do. Okay, so we go in the Chargeback section in the UI. These are all where all the rates are defined. We have a default one. You might have multiple rates. You might not be able to read it, but there are for CPUs, memory, and network. You can define different rates, fixed or based on usage. And once you have these rates or different rates, you can assign them to your Openshift clusters, right, to your Openshift providers. Once those are assigned, we can move to another part where you build the reports. So again, the reports are giving you the ability to do all the things that we saw in the dashboard, but also the Chargeback reports. So we give it a name. We select what type of report. It is a Chargeback report. We select what are the columns that we are interested in. There's a lot of information here. You might want to select only the subset of information that you're interested in. And once you came up with the selected fields that you want to see in your report, you can change the format if there's anything that you want to tweak, and filter them. So we are creating a report for all the projects on all the providers that are attached to these CloudForms. Once you define your report, then you have to queue the execution. And you can schedule the execution once a day, once a week. And now we're queuing it right away. We have to wait a little bit for all the metrics to be collected, accumulated, and summarized in the report, which is now ready, and we can look at the data. And we have all the information about the costs per resource, and at the end, the total. And obviously, these can be both, well, can be downloaded in different formats, CSV as well, but it can be tied with your billing system. So this is the information on top of which you can then move on and do the billing. And this can be integrated with your own workflow in your company. Now, if we want to move even further, and we really want to do that, if we are already reached these number of cluster that we want to manage consistently, and we do have internal infrastructure and external public cloud, then Red Hat has a solution for you, which is the Red Hat Cloud Suite, which comes with everything you need to build and run your modern application. It comes with the Quick Start Cloud installer. We'll see what's that about. We saw Cloud Forms, and comes with Red Hat Enterprise Virtualization, Red Hat OpenStack platform, Openshift, and obviously supports VMware, Azure, Amazon, and GCE. Also comes with Insights, Satellite, and self-storage, and we'll go more into details for those ones. So the image that we had, the diagram that we had earlier, gets expanded furthermore because we have CloudForms and OpenShift Enterprise and your virtualization, private cloud, and public cloud of choice. You also have your platform and storage in the package, and Satellite with its Quick Start installer and content management. I want to summarize before moving forward with the items that I mentioned earlier. I just want to summarize what we did so far. So we started with an individual beginner that wanted to get acquainted with containers using CDK, the OpenShift local that comes with CDK. The deployment is rather simple. On Windows or Linux, you can just double-click it, and the content comes from that CDK OpenShift deployment itself. Then we moved on with Steph talking about the infrastructure with the OpenShift container platform, which is installed, deployed with Ansible installer, and soon from CloudForms as well. And for more details about this, please come tomorrow at the presentation that I mentioned earlier. We will have more details about that. The content comes again from OpenShift. The management, as we saw, is CloudForms and Cockpit for hosts. Runtime for the next step, which is the Cloud Suite, again, OpenShift, the Quick Start Cloud installer. Content comes from Satellite, and we'll see that in a minute. And the management, you have CloudForms, Cockpit, and Insights. So let's close those gaps about the solutions that I just mentioned. So what is the Quick Start Cloud installer? It is basically an image that you can boot from any machine and start deploying all the other solution that comes within the suite. It is the Red Hat Enterprise Virtualization, OpenStack platform, and CloudForms. And more items will come into these quick installer so that you boot out of these and you install all the solutions that you need. Insights. So I mentioned it earlier. In the package, we have Insights as well, which is a proactive solution for you to identify misconfiguration or risky container images. What we do here by collecting a massive amount of information from live system, running system, we come up with best practices and knowledge base that we formalize into rules, and we are able to apply to your containers and inform you that there might be a misconfiguration or a configuration that is not optimal enough for you, or even some vulnerability. This is an example of a result that came from Insight. It is telling you not only what is the detected issue on the container that you just analyzed, but it also tells you what are the steps to resolve, because the knowledge base is not only about the problem, but also how to solve it. Again, another example with a detected issue, a security issue detected, and how to solve that. And finally, Satellite, that you might be familiar with, but within the scope of this talk, Satellite is the owner of the content, is giving you a place where to store the images, your content. And it already came out with a registry in the previous version for your images, where you can connect multiple Openshift clusters to that registry and benefit from those images. But we will take that in a step further, making the registry writable and based on the enterprise registry, so that we can leverage both the ability of satellite of doing the promotion of these images from library dev production to your Openshift cluster, multiple cluster consuming the same images that can be promoted across every single stage. So we saw as with the Cloud Suite, you have everything in place from your internal infrastructure, external cloud, Openshift, container platform, management, content, and proactive analysis. So with that, we can move to questions.
So with the chargeback model, which you were showing previously, does that also charge back for the containers or the pods which are down? Is that a way to segregate that?
Okay, so the question is about chargeback, and I'll try to answer that. So the question was about the rates and whether they take into account also containers that are down. Okay, so this is based on metrics, which means that if there is a metric, a resource consumption, then yes, we take that in account. If they're not spawned up because they're crashing, they're not running, so we don't take those in account because they're not taking effectively any resource themselves. Your infrastructure might have some consumption trying to spin them up, but it's not considered. The other thing that maybe I forgot to mention is that we do chargeback also on those projects and those pods that obviously died during the past month, right? Which means that if you have a short-living project, just for a few weeks, then we obviously take into account that because it consumed resources. So we do chargeback against those. We don't do chargeback against resources that were not taken because the container was down.
So that's a live metrics which is done on CPU and the memory utilization.
That is correct.
And what is the period for which it kind of calculate? Every 60 minutes, every 60 seconds? How does that calculation?
Okay, so the technical details are that the Openshift itself is collecting the metrics every 10 seconds. We do an aggregation over 20 seconds in cloud forms. Then we do roll-ups every hour. So the smallest sample is 10 seconds, and then we aggregate those up. Okay. So the question is, what are the actions taken on the images that are not compliant? Okay. So there's a policy out of the box, which is taking the action of marking them not compliant in cloud forms, and then not compliant with an annotation inside Openshift, saying that that image failed to pass the policy. Openshift will leverage that, making sure that no pods will be running, right? But that's another policy within the cluster of Openshift. You might have an internal cluster that is for QE development, where you'll be more flexible. Not from the management side. From the management side, we are informing that these are.
But from the infrastructure side, we make use of that information to apply that policy or to roll out an update. And Openshift is very powerful in that way.
Yeah, That depends on how you configure your cluster. Yes. Okay. Yeah.
Yes.
Yeah, that is the point. So management informs you. You might have different clusters with different strictness about those policies, right? And then, yes, one can prevent them to run regardless, always. And in another, you say, okay, it's internal, maybe I don't care.
So to follow up on that, can you also do any kind of synthetic transactions that you want to add also
Can you repeat just a second?
Yeah, just can you do any kind of synthetic transactions within the platform that you might want to also test for?
Synthetic transaction.
Synthetic transactions, moment test, timing of some type of transaction, in-end transaction. Can you do that?
I believe you talked about custom code in
Yeah.
platforms that you can.
If this information, if this information is collected, you can leverage that. I'm not entirely sure what you mean by synthetic transaction. We can talk about it. It might be that we use different terminologies for. We'll catch that later.
So Red Hat Cloud Suite, is that licensed product or it's freely downloadable, and plus we pay for support? How does that work out?
That's a great question, and we have someone here that I'm sure is familiar with the details. Yeah, the question is, what is the licensing of the cloud suite? And I'm not sure if you mentioned pricing as well. I don't know, but
yeah.
is
that the support which comes into the picture, or it's freely available to download? How does that work out?
I'm not sure if we have an email for it.
So what kind of licensing model happens for that?
So it's a subscription. And then you subscribe all of the managed nodes that you're going to be using with our HCI cloud infrastructure, and then it gives you access to CloudForms. So once you have subscribed to systems and a subscription to CloudForms, we don't charge you for the number of CloudForms instances, we just charge you for all of the managed infrastructure. Okay. So if you have 100 nodes of OpenStack and you want to use our HCI to manage it, we charge for 100 nodes of CloudForms, or our HCI or whatever the subscription.
Everything's not.
Yeah.
Okay.
cool.
If you want to buy.
So I think we're up. Thank you, everyone.
Thanks for coming.